Okay, so the next video is just operations with complex numbers. The first one we have 4 minus 6i plus 2 times 2 minus 3i. Okay, with these, you want to get rid of your parentheses first. Sometimes you have to do distributive properties. So that's going to be 4 minus 6i plus 4 minus 6i. I combine my real numbers, so 4 plus 4 is 8. And then I also combine my imaginary parts, that's negative 6 minus 6, which is actually negative 12i. And that's my final answer. This one right here, negative 5 minus 8 minus 3i. So the first thing I want to do is I want to get rid of my parentheses, so I put a 1 here and I distribute my negative 1. So that's going to be negative 5. Instead of positive 8, that becomes negative 8. Instead of negative 3i, that's positive 3i. And I combine my real parts. That's going to be negative 13 plus 3i. This guy here is just a little tricky, okay? It says we need to fill in the blanks. And so we were trying to fill in this first blank here. So I know some number minus 14 is going to give me my other real number, which is negative 10. Okay? So basically you just kind of have to focus on that part that you're trying to find. So I'm trying to find the real part because it doesn't have an I next to it. So I'm going to say, okay, well, what number? So I'm just going to call that x. I add 14, and the number that should go there should actually be 4, because 4 minus 14 is equal to negative 10. Second one, very similar, but now we're going to be talking about our imaginaries. We have 3 and minus something there is equal to negative 2. Now this one's a little bit tricky. I'm going to put a negative x there. So I'm going to subtract 3 from each side. So negative x is equal to negative 5. We want to get rid of that negative, so we divide by negative 1. X is equal to 5. And is 3i plus negative 3 or 3i minus 5i equal to negative 2i? Sure enough it is. So your answer to that one was 5. Number 5, this is just simple multiplication. We have our 7i and our negative 3i. We multiply 7 times negative 3 times I times I. 7 times negative 3 is negative 21, and I know that that's the same thing as I squared, which is equal to negative 1. And so my answer is positive 21. This one here, negative 2i times 2 plus 6i. I would do distributive property. Negative 4i plus negative 2 times 6. Actually, I'm going to not put the plus there. Okay. Negative 2 times 6 is negative 12, and then I times I is I squared. I know that I squared is equal to negative 1, so I'm going to replace my I squared with negative 1. This is negative 4i plus 12 now, but remember, we need to switch their spots to have it in standard form, so it should be 12 minus 4i. Okay, this one right here is one of the ones where you should do your box method or FOIL. I'm going to stick with the box method just because I think most of you are familiar with it. So on one side is going to be 4 plus 7i, the other side is 4 minus 8i. So I go through and multiply. 4 times 4 is 16, 4 times negative 8 is negative 32i, 4 times 7 is positive 28i, 7 times 8 is 56i squared. So I have 16 plus 28i minus 32i plus 56i squared. I combine my like terms here. 16 minus 4i plus 56i squared. I change my I squared into negative 1. 16 minus 4i plus 56 times negative 1. And you can do this in less steps. Minus 56. I combine my like terms. 16 minus 56 is negative 40. So it's going to be negative 40 minus 4i. And that's my final answer. 8. The only tricky thing about 8 is the fact that you have to draw a box with it. So just remember, if it's squared, you make a square. Squared, make a square. So this is going to be 6 minus 8i, 6 minus 8i. 6 times 6 is 36. 6 times negative 8 is negative 48i. Negative 8 times 6 is also negative 48i. Negative 8 times negative 8 is positive 64. I times I is I squared. 36 minus 48i minus 48i plus 64 I squared. And again, there are steps that you can skip. I'm actually going to make this into a negative 1. So this is going to be 36 minus 96i plus 64 times negative 1. 36 minus 96i minus 64 now. I combine my like terms. 36 minus 64 is negative 28. So this is going to be negative 28 minus 96i. Number 9. This one's a little bit fun. Oof, did not want to do that. Just want to change the color. Okay, this one was 2 plus 5i and 2 minus 5i. 2 times 2 is 4, negative 10i, positive 10i, negative 25i squared. What you notice is those are equal to 0. So what I end up with is, I'm going to skip a few steps with this one, 4 minus 25i squared. I know I squared is negative 1, so it's going to be 4 times 25 times negative 1. 4 plus 25. So my answer here is simply 29, and that's because these are complex conjugates. Okay, so complex conjugates, and that's going to be a key term here. Okay, last problem. Again, it's multiplication. So I'm going to do a box. You have your 6 minus 2i times 3 minus 4i minus 5. 5, oof, sorry. Plus 3i. So I'm just going to separate this. I'm going to do the multiplication in the box right here. So 6 minus 2i, 3 minus 4i. 18, negative 24i, negative 6i, 8i squared. 18 minus 6i minus 24i plus 8i squared. I combine these. 18 minus 30i plus 8 times negative 1. 18 minus 30i minus 8. I combine these. 10 minus 30i. Okay, I do the same thing for the other side. I have this minus 5 plus 3i. I just do distributive property here and here. That's all I can do. So this is going to be minus 5 minus 3i. And so all we do is we combine our like terms. 10 minus 5 is 5. Negative 30 minus 3 is negative 33i. And there you go. You're all done.